SAT prep time, non-calc geometry action going on. A summer camp counselor wants to find a length x in feet across a lake as represented in the sketch above. The lengths represented by AB, EB, BD, and CD on the sketch were determined to be 1,800 feet, 1,400 feet, 700 feet, and 800 feet respectively. That means in that order. Segments AC and DE intersect at B, and angle AEB and angle CDB have the same measure. What is the value of x? Well, because those two angles have the same measure and we have these two vertical angles that are congruent, these two triangles are similar to each other. So I can set up a proportion with some of the known side lengths. Let's label our side lengths. All right, so I've got my triangles labeled here with their lengths, and I also started a similarity statement because I think that'll help in setting up our proportion. Well, I have triangle AEB is similar to triangle which one? Well, E needs to match up with angle D since they have one mark on them, and I know B needs to match up with B because it has two arcs on it, which leaves C to be the first one there. Now I can set up a proportion. I know that EB with the 1,400, which is this one, matches up with BD, which is the 700 right there. So let's set up a proportion with that information. So we've got 1,400 over 700, the comparison of those two sides. Now, I want to figure out what x is, and that comes from my larger triangle, so it'll be associated with that 1,400. I got to have it in the numerator. Okay. Now the other side that's associated with that x right there that we want is my DC side, right? Because that was AE, which is the first two, and DC, first two in the similarity statement there. So I'm going to have 800 right here. Whenever I set up a proportion, I always double check things and say, okay, well, the 1,400 is for my large triangle as well as the x. Large triangle's up top, and then my smaller triangle is down in my denominator. And then when I look at the 1,400 and the 700, those are the corresponding sides of the two similar triangles, and the x and the 800 are also corresponding sides. So we're agreeing going across, we're agreeing going up and down. Boom. Let's cross multiply and solve. But hold up, those are some big numbers. Perhaps we can go ahead and simplify. I can cancel out some zeros here, and then I'm left with just 14 over 7, which is 2 over 1. Let's leave it as a fraction right now. So 2 over, not x, 2 over 1. And then over here, I'm going to have x over 800. I can't do any simplifications there. But I can do 2 times 800. That's going to be 1,600 or 1,600 equals 1x or just x. Boom. There's my answer. Since this is free response, we're going to have to grid it in. That's 1,600. So I'm going to be 1, 6, 0, 0. The grid in is what counts. You can write this in up here, but that's really just to organize yourself. You have to grid those bubbles in. That was dope. The expression above is equivalent to a divided by the quantity x plus 2 squared, where a is a positive constant and x cannot equal -2. That's a domain restriction. It's making sure that this expression here is defined. What is the value of a? Well, since that expression above is equivalent to a divided by x plus 2 quantity squared, I can set up this equation. All right, so now I have what's called a rational equation. Now what I need to do is either get all common denominators, and then I can work with just the numerators, or I can multiply through by my least common denominator to cancel out those denominators, resulting in just my numerators. Either way is fine. People do them differently. Your call. I decided to multiply all of my numerators by the exact same thing, my least common denominator, and that would be x plus 2 quantity squared. That's going to go ahead and cancel out this denominator. This will be canceled as well, but it will leave behind one of the x plus 2s, and then this one will be completely gone as well. So now what I have is the 2x plus 6 minus 2 times that leftover x plus 2, right? Only one of them got canceled, equals a. Now it seems weird. I'm like, I need to get the value of a, but I have these x's in here. What's going to happen? Let's just see what goes on here. I'm going to distribute that -2, and I get 2x plus 6 minus 2x minus 4 equals a. What happens with those two x's? They cancel, right? 2x minus 2x is gone. Now I'm left with 2 equals a. There's my answer. Boom diggity. Since this is a free response question, I'd have to grid in my answer. There's two acceptable ways to do this. I can either put a 2 filled in right here, and you can write your 2 up there if you'd like. You don't have to write it up there. Just a way to keep organized. Your other option is putting a 2 all the way over here. Either one's okay. Just make sure that you are gridding in, obviously, the correct answer. Cool. Awesome. See ya. If a equals 5 root 2 and 2a equals root 2x, what is the value of x? Well, perhaps I can go ahead and substitute this right here in for a into that second equation there. So that would mean I'd have 2 parentheses and then 5 root 2 equals square root of 2x. All right. Well, I could multiply 2 and 5 together to get me 10 root 2 equals root 2x. Now, how the heck am I going to get rid of these square roots? How about I go ahead and square both sides? Remember, we got to square the entire thing. So that means I'm going to have 10 squared, which is 100, and root 2 squared, which is 2, so that'll become 200 right here. Equals, and then it's just 2x, because the squared and square root here will cancel each other out. There's something else to, distribute that to, like we had the 10 on the left-hand side. So now I'm going to go ahead and divide by 2, and I get x equals 100. Cool Benji. All right, so where I bubble this in, you can go on the left or to the right. I'm just going to go with 1, 0, 0. That's 100. You can write this up here if you like, but you do not have to. They grade you based on what you bubble in, and make sure you're bubbling in a little better than me here, nice and filled in. Ah, that's beautiful. Did you know that a dull pencil to bubble in will save you a little bit of time? Fun fact. Woo! For a polynomial p of x, the value of p of 3 is negative 2, meaning when I substitute 3 in for x and I evaluate, I get negative 2. Which of the following must be true about p of x? My first 3 answers here are all x minus 5 is a factor, x minus 2, or x plus 2 are all factors. If they are going to be factors, when I do say synthetic division or I evaluate with 5, 2, or negative 2, I'm going to get 0 as my answer or 0 as my remainder in synthetic division. So right off the bat, I know that these 3 are not the answer and that choice D is my correct answer. But let's make sense of choice D, shall we? Because math, and who knows, maybe there'll be another time where there's 2 similar answers and you have to pick. The remainder when p of x is divided by x minus 3 is negative 2. X minus 3 is the factor associated with this x value. That would be my root or my 0. So when dividing by x minus 3, I would be using 3 for synthetic division. Now, hopefully one of these 2 forms of synthetic division look familiar to you. I use the green one. And here we'd have a remainder of negative 2, or with my red one, it would look the exact same at the end there, remainder of negative 2. Now, our remainder theorem states that the remainder when dividing, whether you're using synthetic division or long division, the remainder ends up being the same as if you were to evaluate or do direct substitution with that same 3 that we have here, here, or there in purple, and now circled in red. So choice D there is exactly what we have. If we're doing the remainder when dividing is negative 2, it's the same as direct substitution with that 3 as well. D is definitely our answer. Well, we were able to do it with process of elimination as well, which is way quicker. Move on. Always good to make sense of things. See you later. For what value of x is the function h above undefined? We might be looking at that and being like, hey man, that's easy. It's already factored and things like that. We can just say it's 5. Hold up. It's not factored, okay? Because we have addition outside those parentheses. So even if I put 5 in for x, I'd get 0 plus 4 times 0 plus 4. That's going to equal 4. That's not undefined. So let's take a closer look at that denominator. If I want this to equal 0, well, I don't want it to equal 0, but I want to find out what's going to make it 0. Let's go ahead and set it equal to 0. Now I'm going to FOIL out the x minus 5 as x minus 5 times x minus 5 is going to be x squared minus 10x plus 25. Now I'm going to distribute this, and I'm going to get plus 4x minus 20 plus 4 equals 0 still. And now I'm going to go ahead and combine some like terms on my left-hand side. I'm going to have x squared. Then I'm going to have, let's see here, negative 10x and positive 4x gives me negative 6x. And then I've got 25 minus 20, that's 5, plus 4 is 9 equals 0. Now I have a very manageable quadratic. Again, this is my denominator, right? So I want to find out when it equals 0. That's going to tell me where it's undefined. So if I factor this, what multiplies to 9 and adds to negative 6, that's going to be x minus 3 and x minus 3. Or x minus 3 squared. So that means x equaling 3 will cause it to be undefined. That is my answer to the problem. So since this is free response, we got to go ahead and grid this in. I'll pop a 3 right here. Whoop. And then fill it in. We are good to go. That's a tricky problem right there. I'll be honest. Initially, I thought it was going to be 5. And I was like, hold the phone. We got addition going on outside those. We got to FOIL. We got to distribute. We got to set that equal to 0. Go through the whole process, solve a quadratic. And that was awesome. So yeah, if a squared plus b squared equals z, and a times b equals y, which of the following is equivalent to 4z plus 8y? So what I'm looking to do here is I'm just going to go ahead and substitute in my a squared plus b squared in for z. I'm going to sub that ab in for y. Now I can go ahead and distribute the 4, and I'll get 4a squared plus 4b squared, and then I just have the 8ab. I like to use parentheses to show that I'm substituting something in. All right, so we could do some rearranging and show that this can be factored as a perfect square trinomial, but not a whole lot of us will remember how to factor a perfect square trinomial, especially when we have two variables. If I look at my answer choices, though, I need to get 4a squared, and I also need to get a 4b squared. There's only one option here that's going to do that for me. Since all of these binomials are essentially multiplied by themselves, since they're being squared, my choice B, I'd have 2a times 2a gives me 4a squared. I'd have 2b times 2b gives me 4b squared. And within the foiling, I'd get that 8ab. That's the only option that'll give me those 4a squareds and the 4b squareds. So that is my clear choice. Hope that helps.